This is lesson 52 from Saxon Algebra 1. We're going to start by talking about and reviewing the denominator-numerator same quantity rule. So I'm going to show you some examples of this. The denominator and the numerator of a fraction can be multiplied by the same quantity without changing the value of the fraction, as long as you're not using 0. So it can be any other quantity, and we're going to do some examples that will show how this works. So they want you to add two fractions, a over x and b over x plus y. So to add these together, we need to find a common denominator, and we need to specifically find the least common multiple of both of those denominators. And we've gone over this before, finding least common denominators, but when you have variables like this, oftentimes in this case, the least common denominator is just each of these. So we need to multiply them together to create a new denominator. So x times x plus y is really the only least common multiple these guys can create together. So I'm just going to rewrite both of these fractions with this new common denominator of taking our denominators and just multiplying them by each other, because then we know they're both included. And to transform both of these, we need to recognize that to turn this fraction into a fraction with this denominator, we are going to have to multiply it by something to create that. So we had to multiply our original a over x by something in order to create this new denominator right here. So we need to acknowledge, what do we need to multiply it by to get that in the denominator? And what we had to multiply it by, when you look at this, is an x plus y in the bottom here, because there's already an x here, but we also need to include this new x plus y. So we have to multiply it by an x plus y, and we can't just randomly multiply the denominator of a fraction by something like this. So we need to also multiply an x plus y to the numerator. And this is the example of this denominator-numerator same quantity rule. We are allowed to multiply this denominator by anything as long as we're multiplying the numerator also by that same thing. And we made the decision to use the x plus y because that's what we needed to add to this x to create our new common denominator. So the x times the x plus y can just be rewritten like you see here in the denominator. And then the numerator will become a times x plus y, because we multiplied this a times this x plus y. So that created this new fraction. And we did not actually change the value of that fraction, because we could now, if we wanted to go back, we could cross both of these out, and we still have that original a over x. So we didn't change the quantity of it, but we don't want to get rid of those, so I'm going to take my little x's off, because we wanted to transform it. We also now want to transform our original other fraction, which was b over x plus y, and we need to multiply that by something to get our new fraction with our new common denominator that we decided needed to be x times x plus y. So we already have an x plus y accounted for here. So what do we need to multiply that by to get our new x times x plus y? Well, we just need to multiply it by that additional x. So that's all it needs to multiply by, and because I'm multiplying that to the denominator, I also have to multiply it in the numerator. So that gives us, now when I multiply the b times the x, I can just write it as bx on top. So I will rewrite all of this, because remember, we started with two fractions adding together, and we're rewriting them as two fractions again with new common denominators. So I'm just going to transfer this up of what we already had written here. So I'm going to write a times x plus y, and then I'm going to transfer this one up here, and this is bx. So now this is our new addition we have here. And from this step right here, I'm going to draw an arrow, and I'll switch colors for you so you can see what we're changing here. So we're adding these two fractions together. So I'm just going to rewrite my new common denominator, this time just rewriting it once, because I'm going to add the numerators together above it. So I'm keeping my same denominator, and now I'm going to rewrite this part of the numerator, the a times x plus y, and then I will add it, so don't forget that symbol, add it to our bx over here. And that is what kind of brings them together. Now I'm boxing this, but I'm not quite done because there are many different correct forms of this answer. We could stop here and call this a correct form, or you could distribute this a and rewrite it as a times x plus a y, and then still keep writing our bx. And then in the denominator, we could leave it as is, or we could distribute this x. If I distribute it, it becomes x squared plus xy. So that's one way you could leave your answer. So the book is reminding us there's many different ways to leave it. If your teacher asks for a very specific way, you can leave it that way, but you can box any of these answers along the way. So again, in these exercises, you're looking at the denominators that you're starting with. Usually the least common denominator when you're working with like a binomial is to just multiply each of them together. So because we had an x and an x plus y, we multiplied them together to get x times x plus y. So, and then as you solve, you figure out what the new fractions are that you've transformed by figuring out what you needed to multiply each denominator by to get that new common denominator. So I think we should do one more example problem because these are a little complicated because there are so many steps here. So let's do another example. We will start, here's one that has three terms. A plus b over x plus c over m plus d. And we'll remember when we have just an individual variable written without a fraction, it's still in the numerator of our fraction technically. So we're going to look carefully at our denominators, so I'm going to underline those, and say what is the new common denominator we need, or the least common multiple of these. Well, there's no way to break them down any further like we would with numbers. So simply the new common denominator is x times m. So we just multiply those two together. So now we're going to create, because we had three terms, 1, 2, and 3, I'm going to write three terms here with the same denominator. So to figure out the numerator, so I'm going to think, how can I transform this first fraction and rewrite it? Well, what changed here is I needed to multiply this x by an m to create x times n. So kind of to the side here, I'll do it in another color. I needed to multiply the a plus b times an m over m so that I could get this xm denominator. And that created up top, when I multiply the m times a plus b, that is what we create on top. So I'm just going to fill that in here because that's our new numerator there. When I take the second term, I had c over m. Now I need to figure out what do I multiply top and bottom to get x times m here. So to get x times m here, I had to multiply x over x to create that. So the denominator makes xm, And then the numerator makes CX, which I will fill in here in red. And then the last one, I'll circle in blue, was just D, just all by itself. But we still need to multiply that by something, because if we need to add it to the other terms, it still also needs to have a common denominator. So if my denominator needs to become an XM, that means I need to multiply the top and bottom by an XM. So now I have DXM. So I'm going to fill that in up here. So now I started with 3 terms, 1, 2, 3. I've turned it into 3 new terms, all with the same common denominator. So because I have all 3 of these, I can now add them together and rewrite it all over the same common denominator. So I'm going to take the first part, the m times a plus b, and then because they're added, I'm going to add it to the next part, which is cx. Then there's another addition symbol, so I'll add that to dxm. And that is where we can box this answer and call it done. Or some teachers might have you distribute that m, so it becomes ma plus mb plus cx plus dxm. I'm just sort of rewriting the rest of it over xm. So either way, you could leave it either way. It's based on your teacher's judgment or your own of how you'd like to leave that answer. And even in the textbook, they left it right here. So hopefully this is a good example. There's some other examples that the book has. And then there's one other topic they talk about in Lesson 52. The last thing they talk about here in Lesson 52 is the overall average. Overall average. So when you average numbers, if you're taking a group of numbers, you usually add them together and then divide by how many numbers you're adding together. But they're going to talk here about the overall average, which is when you maybe average the averages of numbers. So let me show you what they're talking about, because it makes more sense when you sort of see the numbers. So if they tell you the average of 6 numbers, if they say the average of 6 numbers is 8, and then they say the average of the next 4 numbers is 10. So we have 6 numbers that average together to get 8. We have 4 numbers that average together to get 10. If we find the average of those 2 averages, we would say 8 plus 10. When I average them together, because I'm taking 2 numbers, I would divide by 2. So this would add together to get 18 over 2, which would be 9. Now, this is the average of the averages, but this is not the overall average, because this average, the 8, was representing a group of 6 numbers, and the 10 was representing a different set of numbers, only 4 numbers. So it kind of really isn't fair to just average them together as if they're sort of representing equal amounts. So the overall average is going to be the sum of all numbers, so adding them all together, divided by the number of numbers. And I'll show you what that means. So we knew the average of the first 6 numbers was 8. So the sum of the first 6 numbers has to be 6 times 8. Because again, the average of the 6 numbers is 8. So if there were 6 numbers, we knew they had to add up to 48 in some way. We don't know what each of the 6 numbers were, but we know they add to 48. And we can also know that because 10 is the average of 4 numbers, we know we could take that 10 and just multiply it by 4 to get 40. So we know the other set of numbers equaled 40. So we will take our overall average, because that is the sum of all the numbers. So all the numbers added together would be 48 plus 40. So I'm adding the first 6 numbers and the last 4 numbers, and I'm going to divide it by the total number of numbers. So meaning this one was representing 6 numbers, this was representing 4, so all together they're representing 10 total numbers. So when you add this together, 48 and 40, you get 88 divided by 10, so you actually get a fraction, 8.8. So you can see this number here is close to taking the average of these two averages, but this is much more exact because this takes into account that one of the numbers was representing more than the other. So hopefully that makes sense, and you can let me know if you have any other questions about Lesson 52.